Hello everyone, welcome to the session on McCluskey problems. So basically we know that we can simplify using three methods. One is the McCluskey theorem, other one is simplification using Boolean algebra, and then simplification using K-map. So we have already seen simplification using K-maps and Boolean algebra. Please go through my previous videos for clarifications. Now we will see how to simplify using McCluskey theorem. So here we take a sample example problem where we are given that f of a, b, c, d is equal to summation m of 0, 2, 3, 6, 7, 8, 10, 12, and 13. So it is a min term where the min terms are classified and the function is indicated within the brackets. So our first step is to write the binary representation of the min terms in ascending order. So already the minterms are arranged in ascending order here. So I am writing the binary representation of my minterms. So binary representation of 0 is 0, 0, 0, 0, 2 is 0, 0, 1, 0, 3 is 0, 0, 1, 1, 6 is 0, 1, 1, 0, 7 is 0, 1, 1, 8 is 1, 0, 0, 10 is 1, 0, 1, 0. Representation for 12 is 1, 1, 0, 0, and 13 is 1, 1, 0, 1. Fine. The next step is classification of the binary representation of the minterms based on the number of ones in the binary representation. For example, M0 comes in the first category because it does not have any one in its binary representation. M2 comes in the next category. M2 and M8 come in the next category as they have only one in their binary representation. M3 and M6 come in the other category as they have two ones in their binary representation. Actually, M3, M6, M10, and M12 will come in the same category as they all have two ones in their binary representations. M7 and M13 will come in the separate category as they have three ones in their binary representation. Now, the next step is to compare each and every category with the other category so that we will find out where the variable changes from 0 to 1 or 1 to 0. For example, M0 is one category, M2 and M8 are other is the second category, M3, M6, M10, M10 and M12 is the third category, M7 and M13 is the last category. So here we will compare M0 with the second category, M0 with the third category, M0 with the last category. Fine, let's start comparing M0 with the second category. So here 0 and 0 is the same, 0 and 0 is the same, 0 and 1, there is one bit change, okay, and the last bit is the same. So if we are having a one bit change, we will be representing in the table this way. So here we have 0, 2. So whichever bit is changing, we will put a hyphen in that place, right? So you can see the third bit was changing from 0 to 1. So for the third bit, we put an hyphen. So from 0 to 2, the third bit changes. So the binary representation is 0, 0, dash 0. Next, comparing 0 and 8. The first bit changes and all the other three bits remain the same. So there is only one bit change. So again, we can indicate this in the next tabular column. So only the first bit changes and the other three bits remain the same. So 0, 8 can be represented as dash 0, 0, 0. So if we are going to go to the next categories, we all know that anyway there is going to be 2-bit change because there are either 2 ones or 3 ones in the other categories. Hence, only 1 bit change can be taken to the next level, we will not have any other combinations with 0. Okay, so in the similar way, we are going to compare each and every category with the category under it and indicate their combinations this way. The next step is to again categorize this into sessions as we do and compare between these categories. So after narrowing down 4 categories, we will get 3 categories. In these categories, again, we should narrow down and look for 1-bit change. Fine. Let us start comparing. Let us compare 0, 2 and 2, 3. The first 2 bits are the same. The third bit also changes and the fourth bit also changes. Hence, we cannot consider this combination. Now let's try 0, 2, 2 and 6. First bit is the same. Second bit changes. Third bit also changes. Fourth bit is the same. But there are 2-bit change. Hence, this combination cannot be taken to the next level. Let's check 0, 2, 2, 10. First bit changes and the third bit changes. So it's invalid. Next, let's check 0, 2, 8, 10. The first bit is changing, but the second, third, and fourth bit are 0 dash 0 in both the cases. Hence, we can take this combination. So 0, 2, 8, 10. 0, 2, and 8, 10 can be taken to the next level. So since the first bit changes, we will put an hyphen in the first bit. Okay, and the remaining bits will be taken as it is. 0 dash 0 will be taken as it is. So the same way you should be comparing each and every category with the category under that and find out the minterms with the binary representation. After this step, we will be listing the prime implicants from the problem. Check with the question. So these are the 2 narrowed down minterms. Now check if all the minterms here are also present in the question. 0, 2, 3, 6, 7, 8, 10 are present. 0, 2, 3, 6, 7, 8, 10 are present. Whereas 12 and 13 are not present in the final group. So we have to move to the previous section, previous step, and check if there are 12 and 13 in any of the groups. If they are present, we can take the binary representation of that group. So here 8 and 12, 12 and 13, both are present. You can take them 8, 10 and 12, 13 and also include their binary representation in the list of prime implicants. But since 12 and 13 are already present in one same group itself, you can also neglect this first term. So I will only consider 12, 13 are narrowed down minterms 0 to 8, 10 and 2, 3, 6, 7. So my answer will be f of ABCD is equal to this term, and this term. So how to estimate the variable from this term? So this is 1, 1, 0 dash. This 1 stands for A. This stands for B. This stands for C dash since it is 0. And this stands for no variable. That means D has no variable. D variable is not present in the representation. Again here, A variable is not present. This is B bar since 0 is for complement. C variable is not present. And this is D bar since 0 is for complement of the last variable. Again for this is A bar, no B variable, C and no D variable. Okay, so it is A bar C. This is B bar, D bar. And this one is A, B, C bar. So these 3 will form the answer for this question. Hope you will try this and give me your feedback. Thank you.